Hello everyone, thank you for watching this video. Now in today's part of the video, we're going to do some very basic revision for Sec 3 G2 on indices, one of the chapters, right? In this part of the video, it will contain a revision for some of the very basic standard form questions and word problems and indices, simplifying the indices and solving indices equations. Right, and then of course some of the basic revision for simple and compound interest. Without further ado, let's begin. Here's our first question. It takes light 3.34 microseconds. So the question here said microseconds, right? To travel 1 kilometer in a vacuum. From this information, calculate the speed of light in meters per second, giving your answer in standard form. Alright, so there is a couple of things that we need to know. First one, this is 3.34 microseconds, right? So what does micro means? And the question did want us to write meters per second, so I must make sure my units are going to be correct. So micro actually represents times 10 to the power of negative 6. Right, last time you are expected to memorize this, but then now in the recent syllabus, if they were to quote microseconds or maybe nanoseconds or whichever, right, they will give you is times 10 to the power how many. But for the basic ones like kilometer, million, billion, you are expected to know the number of zeros. Okay, then from here I've converted 3.34 microseconds to this. And then our distance is actually 1 kilometer. So I need to change this into meters. So 1 kilo means 1,000 meters. Now that we got the correct units, let's find our speed. So speed is equals to distance divided by time. The distance will now be 1,000 meters over the time, which is 3.34 times 10 to the power negative 6 seconds. Okay, using this, we shall key this into our calculator. 3.34 10 to the power minus 6. And the answer from my calculator is 299401197.6. Now this number is not yet in standard form, so we need to convert this to standard form. And you notice the number is actually quite long, so we can actually convert it to 3 sig fig. Okay, so I'll need to put my decimal place in 2.99 to make it such that it's a number bigger than 1, bigger than or equal to 1, smaller than 10. So it's times 10. Now you notice that this is actually a very large number, right? So our power definitely must be positive power. So if my decimal place is here and I'm going to shift it here, so I need 1, 2, 3, 4, 5, 6, 7, 8 of it. Right, so this one will be 10 to the power of positive power 8 meters per second, corrected to 3 significant figures. Have you gotten the answer? Let's look at one more example for standard form. So in this case, for question 2a and 2b, you notice that 2a and 2b are not very much related, so still be doable. So this is 0.12345 537. So I need to change this to standard form. Just now we had a very large number, right? So when we have a very large number bigger than 1 or 10, itself the power is a positive power. Now I'm going to put this as 5.37 so that the number will be bigger than or equal to 1, smaller than 10. Times 10 to the power of something. Now you notice there's a lot of decimal place here. It's a small number, so the power will definitely be a negative power, right? So this is 5.3, 1, 2, 3, 4, 5, 6. I shifted 6 decimal place, so this one will be power negative 6. All right, have you gotten the answer? Then now let's part B. How do we apply a word standard form to word problems? The question here says the population of Singapore was 5.47 times 10 to the power 6. The area of Singapore is so much kilometer square kilometer. Calculate the average number of people per square kilometer. Question tells me they want people per square kilometer. So this is actually telling me a sign. I'm going to take my population, which was 5.47 times 10 to the power of 6, over my area of the land, 7.18 times 10 to the power of 2, right? And using our calculator, 5.47 to the power of 6 over 7.18 to the power of 2. And that gives me, in my calculator, 7618.38. Give your answer in standard form. The question did say standard form. So I'm going to change this to standard form. That means I need to bring this to make this a number bigger than 1, smaller than 10. Okay, so it will be 7.618. Since there's quite a lot of numbers, so I'm going to round it off to 3 sig fig, right? 7.62 times 10 to the power. So this is a number already bigger than 10. So definitely, so I'm going to have a positive power. 1, 2, 3. 1, 2, 3. So I shifted 3 places. So 7.62 times 10 to the power of 3 people per kilometer square. And I gave this answer correct to 3 significant figures. Have you gotten the answer? Now, next part of the question, we're going to simplify some of the basic algebraic formulas. Before we begin, we need to go through some of the very basic rules. Alright, so basic rules include, if I have multiplication of numbers of the same base, the power will add together. Right, that's number 1. Then the second one, if I have division, then the power will subtract each other. Right, then some of the other common one, a to power n bracket power n, it means these two need to multiply together, n times n. And if I have a to power -1, it'll be 1 over a to power of 0, anything to power 0 is 1. Similarly, we can also change 1 to the power of anything, any base, okay, to power 0. Right, and these are some of the more common ones. Then the last one that you also need to take note of, if I have a fractional indices, so a fractional index over maybe say another color n. So if I have something that looks like that, right, this actually means this is root form. So the fractional over here is actually means root. The denominator is the number of root outside. So if its denominator is 2, square root, denominator is 3, is cube root, right? And then the power n is in the mid, with the power of 8, with a itself. Alright, so these are some of the basic rules that we must know over here. So now let's take a look at our question. Okay, for our question itself, it says, given that this whole thing over here is equals to 3 over m, 3 to the power m, so they asked me to simplify actually. So I have 3 to the power 5 times 3 to the power 0 over 3 to the power -4. Right, it's an equation, so do write down your left hand side and your right hand side. So in this case, I'm going to change this 3 to the power 5 plus 0. Division is multiplication, so it's addition. Then division is minus, right? Be careful, this is subtract -4. So that I have everything to the power of 1 base, right? 3 to the power of 5 minus -4, that gives me 9. And therefore, m will be equals to 9. Okay, have you gotten the answer? Now, of course, for the actual test, class test, or whichever, sometimes teacher will give questions that are harder. So do try and practice, but at least you must know your basics. Right? Let's continue to solving indices, okay, equations with indices in the power form. right? So question B itself says I'm going to solve this. 64 to the power of 4 over 3 equals to 2 to the power n, and they asked me to find n. Now when you notice that the base number over here are very different, okay, for all kinds of question, always change it to the smallest prime factor. That's the easiest and safest, right? So I'll take 64 and I'll change it to the smallest prime factors. So 64 divided by 2, divide by 2 again, and divide by 2 again, divide by 2, until I get 1. So now the number 64 has been changed to 2 to the power of 1, 2, 3, 4, 5, 6. So I'm now going to change 64 into 2 to the power of 6. Not forgetting the outside still have a power. What's the power? 4 over 3. So I'm still keeping my power 4 over 3. And this is still equals to 2 to the power n. Then now we apply the rule. Okay, the power will multiply with each other. The power and the power multiply. So this one now becomes 6 times 4 over 3 to give you 2 to the power n, which leaves with 6 times 4 over 3 is power 8. So therefore, n is equals to 8. Alright, have you gotten your answer? Let's try a few more questions. Next question, the question over here, 6a, simplifying the indices, a to power of 3 times a to power negative half equals to a to power of n. So when we have multiplication, we add up the power. So a to power of, 3 plus negative half. And that gives you a to power of 3 minus 0.5, that's 2.5. Or either I will not write it as a decimal. Okay, so usually I'll write it as a improper fraction. But of course, in this case, it's a nice number. So if you really want to put 2.5, no problem. Alright, oh sorry, wait, let me write this properly. This one's supposed to be, this side is a to power n. This one is a to power 5 over 2 after simplification. So therefore, n is equals to 5 over 2. Okay. Have you gotten your answer? Next question, B. We are going to solve equation. So let me write this down, copy down this equation. Part B, 16 to the power of 3 over 4 divided by 8 to the power of 4 and equals to 2 to the power k. So we're supposed to find the value of k over here. So like we can see, the base over here has 16 and 8 and 2. So in order to prevent any confusion, whichever the best, right, simplify everything to the smallest prime factor. So dividing by the smallest prime factor, I get 16 to be equals to 2 to the power of 1, 2, 3, 4. So I'll replace 16 by 2 to the power of 4. There's still a 3 over 4 outside my bracket over here as the power, right? So remember to write it down. Divided by, what is 8? 8 divided by 2. So 8 is now changed into 2 to the power of 3. Not forgetting, outside there's still a power 4. So we must write down the power 4. Okay, and now let's simplify. So this one will be, I need to multiply the powers together. So this will give me 2 to the power of 4 times 3 over 4. That will give me to the power of 3. Divided by 2 to the power of 3 times 4, 12. Okay, and 2 to the power of k. Then for this kind of equation, when there is division, we subtract the power. So 3 minus 12 to the power of k. So 3 minus 12, that will give me negative 9 to the power of k. So therefore, from here, k is equals to a number -9. Alright, so the N level is actually just this basic standard, but of course in school teachers will definitely give you some other traps of questions. Right, so do remember the basic skill over here, change everything to the smallest prime factor. Okay, sometimes they might give you equations such that is equals to 1. Okay, in this case, remember anything to the power of 0 is 1. So I can change my 1 to the power to a base 2 with a power 0. Or similarly, if the question have or in terms of base 5 or base 3, you can also change the 1 to 3 to the power 0 or 5 to the power 0 accordingly. Alright? Okay, now with that, we'll move on to the last part on simple and compound interest. First question, simple interest. Liu invested some money for 1 year at simple interest rate of 1.8% per year. At the end of the year, it was worth so much money. So how much did he actually invested, right? So we know that a few different methods to do this question. And first one, formula I equals to PRT over 100. But since this is a simple interest, we can also use a simpler way to work out the original amount, right? At the end of the year, this person invested 1.8 simple interest. So I'm adding on to my 100%. I will earn the interest of 1.8%, and that gives me 101.8% by the end of the year. So when they give me this amount 1272.50, that is actually 101.8%. So 101.8% represents the amount of money 1272.50. I can work back to find my 100% by taking 100 over 101.8 times 1272.50, or whichever other logical method. Okay. In this case, I got my answer 1,250. So my original amount, how much he invested, this will be the original amount. Right, so please read question carefully to see what is it that they really want. Next question, question number 3. Right, this is on compound interest. Sam invests 2,000 for 3 years, so our P is $2,000. Right, number of interest rate at 1.65% per year. Now the question says compound interest. They did not mention compound monthly or whichever, so we'll assume that it's going to be compounded yearly. So we check that this one, the time period end will be 3 years. Okay, so that we check everything compounded yearly, everything is in years, so nothing to change. So this one is correct. We're going to use our formula. Okay, formula always, I know a lot of students just write P equals P times something, right? But always remember the formula begins with total amount. There's always a left-hand side to your formula. And in exam, this will be on your exam cover page. So please do go and look at it and double check if you need to. So how much is the investment worth at the end of the year? So this is actually asking for the total amount, which is what we want. So we just need to plug in the numbers over 100 and compounded 3 times. And then we'll be able to get our answer to the power of 3. Alright, and for money, it's always in two in two decimal places. So I'll round this off to $2,100.64 to be exact. Okay. With that, we have come to a bit simple end of this basic revision. If you want to find out more about simple interest and compound interest, please watch my other videos for simple interest and compound interest. Alright, I'll see you for our next lesson. Bye.